should be equivalent to 16, again, to the power of 1. Well, I know 4 times 4 is 16, so wouldn't that be 2 times 2 is 4? And then, so there we go. We have another 2. Okay. Oh, this one's a tricky one. What if I gave you 8 to the power of 2/3? Okay, not a biggie. We're going to do this the exact same way. So let's go ahead and do 3 blanks. But this time, it should be equivalent to 8 squared, which is simply 64. Okay, so what times what times what gives me 64? Oh, we just did that one earlier. That was, 4 times 4 times 4. Now, all we were doing was simply taking the square root of 4, the square root of 25, the cube root of 8, the fourth root of 16. Now, this one's kind of weird. We were simply converting radicals into rational exponents. Way back on page 8, we actually discussed this, so let's go ahead and write this out. I have my radical, and inside my radical, I have radicand, which consists of my base raised to its exponent, and don't forget about your index. Now, to convert it from radical form into exponential form, it'll look like this. The nth root of a to the m power is equivalent to base a to the power of m over n. So we would summarize this by saying, when a base is raised to a rational or a fraction exponent, it can be written as a radical, or vice versa. If you have a radical, you can switch it to an exponential form. So last example. Let's take the fourth root of x squared y z to the fourth. First thing I would do is probably recognize that each of these are being multiplied, so we can separate them into factors. Now, this index is going to be applied to each one of these. So let's go ahead and start by saying x to the power of 2 over 4 times y to the power of, well, technically that's a 1 over 4, and times z to the power of 4 over 4. Last thing I would do is just try and reduce 2 over 4, that's equivalent to 1/2. So x to the power of 1/2, y to the power of 1/4. And of course, 4 over 4 reduces to 1, so that would be z, well, just z. Alrighty, that's it.